This morning, we are presenting our research about development of a program to automate CAD in creating assembly structure for bill of material. Most automotive companies in Indonesia, they have headquarters in other countries such as Japan. They do research and development in the headquarters and do manufacturing in Indonesia. For manufacturing operation, the local company need to take necessary data from its headquarters, such as CAD data, specification, and other related documents. Since generally they are joint venture company, the data management in the headquarters and local company are not the same. It means that the product data management or PDM system in the headquarters and in the local company is somehow not fully integrated. Therefore, it creates a non-productive time because the local company should collect and put the data manually to make a CAD assembly model. The problem arising from this situation is since the CAD data, SPL, and other documents are sent separately, there is a need to assemble the product manually in the local company in terms of the CAD assembly data. Of course, it is very time consuming as there are about 6,000 parts in motorcycle and up to 30,000 parts in car. Then later on, they have to import SPL file into PDM and attach the corresponding CAD parts. Then it is synchronized. So it needs to automate the manual process. Let's look into PDM. PDM is a software or system to control product-related data, such as drawing and technical specification. And of course, it is a centralized data repository for all data related to all parts. It's also as product structure management, workflow management, and configuration management. The primary capability of PDM are controlling and securing product-related data, improving the ability to quickly find and reuse information, sharing product knowledge, and collaborating with other departments. The ideal PDM integrates all different product data, CAD, SPL, or structured part list, and other non-CAD documents. In the ideal system, the CAD and PDM should be integrated, where CAD data is checked into PDM system, and next in the later activities, such as design review, all departments will use this CAD data in the PDM and view the data in PDM, doing annotation in the PDM, regardless this is the CAD user or non-CAD user. However, in our case, so in this case we are not disclose the company name, CAD and PDM is not integrated in a way that CAD data is attached to SPL that imported into PDM. Later, both files are synchronized. By doing this way, the CAD view is not generated inside PDM, so that non-CAD user cannot see the 3D view of the part assembly. The proposed solution is to generate assembly inside CAD system automatically. Of course, this is based on the structure defined in SPL. And later on, it check in into the PDM. By doing this, there are benefits such as 3D view will be automatically generated in PDM and the pre-check can be done by the CAD engineer. The program to do that is called XL to CAD. Now we move to development stage. The code was developed using waterfall development method since it is simple, clear requirement definition, and no complex relation with other systems. The process consists of requirement where the file Excel and 3D CAD data is available and is needed to form the 3D assembly in CAD system automatically. Then we generate the architectural design where we have specification inside the SPL file and design inside the CAD data, then those two data will be integrated into CATIA P5 using XL to CATIA codes. Then this assembly data in CATIA will be checked into the PDM. The next step is detailed design. In this case, we need to specify all the detailed configuration of the code. The two main functions in the program is to customize the Excel format and to continue generating the CAD assembly. The customize function is needed to synchronize the Excel format with the information available. And the function to generate the assembly will start with opening or selecting the Excel file. Then after it's open, running CATIA to create the assembly automatically. The next step is coding. It starts with reading the Excel setting inside the customized file. Then open the Excel file. Then run CATIA to create the root product and get SPL data from Excel file. Then create the product structure and assign part properties such as part number, part name, etc. And finally create log file. Next step is testing. In the testing, the result will be compared between the assembly structure in CATIA and Excel or SPL. It can also be seen in the report. The report will be shown how many CATIA successfully loaded into the system and also the information regarding how many unloaded parts and in which row number of the SPL or Excel file. And here is the example of the program. At the back, there is an Excel file. It contains the structure of the product. It consists of first column is the level, second column the part number, part name, and the file location. In the front, this is the Excel to CATIA program. When we run this program, we'll start with doing customization on the format to meet the format in the Excel file. Then also the location file. So now we select the Excel file that contains SPL, then run CATIA. When we finish, we can see the report, how many product total, how many product is loaded, and this is the example of the assembly part. Another case is if CATIA file location is not generated the view, but only the product structure. In this case, we will look at the result. During the loading, there's no CATIA file is loading, and when we look at the report, out of 91 parts, none is found. And therefore, the list is down here, showing that there is no parts found or later loaded. However, inside the CATIA, there's a product structure generated according to the SPL. In summary, Excel to CATIA code was built to form a CATIA 3D file assembly automatically based on the SPL in Excel file. The code is written in VB6. The reason is for better compatibility with CATIA because scripting in CATIA is natively uses VBScript. The result on the subset of SL to CATIA in uploading CATIA 3D files and arrange it into assembly has been done, and the result shows that Excel to CATIA can do its task very well. Thank you.